Hello everyone, welcome to Eduxcite classes. In today's class, we will discuss about the angular momentum and the kinetic energy. If you have not watched my previous video, please check the complete playlist. A small request to please share the video and solve with me. I will give a time for pause. So please pause the video and solve with me. Even you can download the PDF, the link is given in the description. So these are the formula that are directly taken from your data booklet. So I'll represent the angular momentum. I stands for the moment of inertia. Omega is your angular velocity. Tau is the torque. So change in angular momentum is tau times change in time it takes. Change in angular momentum is also equals to the change in I times omega. You can represent this with the momentum as P equals to m v. Change in momentum is equals to m. M represent the moment of inertia and v is representing the omega. You can link with the kinematics what we have discussed, and the kinetic energy is half mv square. So m here is represented by moment of inertia and v is represented by omega. Similarly, L square upon 2I. So this you can directly use for solving the question. So now make yourself proud and pause the video and solve question number 1. Okay, so we will use the conservation of energy, nothing but initially it is at a certain height, so it will have a energy of mgh, gravitational potential energy. Now this energy is converted into your kinetic as well as rotational kinetic energy. So half m v square plus half I omega square. Now in moment of inertia is already given in the question, so we have to find out the linear speed, that is v. Okay, so and also omega can be written as v by r. Okay, so radius is capital R, so v by r, and linear speed is represented by small v. Now if you rearrange this formula, capital M G H half capital M v square plus half moment of inertia is half m r square times v square by r square. Now this r square and this r square get cancelled. So if you rearrange this equation, you will get mgh is equals to half mv square, or you can say mv square by 2 plus mv square by 4, right? So rearranging this will be 3 mv square by 4 is equals to mgh. Now again this m and this m gets cancelled, so you will get as, you can say v square is equals to 4gh by 3, or v is equals to under root of 4gh by 3, or you can write 4 as out of the under root to make it 2. Okay, so I hope you have understand how we get out the relation for linear speed using the conservation of energy, that is the gravitational potential energy equals to, when it rolls down, it is having rotational as well as linear kinetic energy. Okay, now pause the video for question number 2, think about it and solve. Okay, so now for the A part, now if you want to solve for the A part, it is to show that the kinetic energy, now whenever you are answering with respect to the moment of inertia or the rotational mechanics, we have to consider both the linear kinetic energy and the rotational kinetic energy. So the total kinetic energy, or you can say the EK, is nothing but half I omega square, that is the rotational kinetic energy, plus half m v square. So moment of inertia is already given to you, which is half m r square, and we have to write down in terms of omega only. Also linear speed is omega times r, so this you can add half m omega square r square. So when you solve this, it will be m r square omega square by 4 plus m omega square r square by 2. So when you solve this, the kinetic energy will come out to be 3 by 4 capital M omega square r square. Okay, this is quite easy. Just remember this will be the both rotational as well as linear kinetic energy. Now for the B part, read out this. A cylinder of mass 4 kg and radius rolls out without a slipping on a horizontal surface and it descends. So let us say this is something like this, okay, and it makes an angle of 30 degree with the horizontal, and let us say this is the cylinder and this is rolling down, okay. This is the ramp on which it will roll down. Now the question says that we have to find out what? We have to find out the final angular speed of the cylinder. At what speed does omega we have to find out final, and what are the values? Initial, I think mass is given to you, radius is given to you, angular speed, that is the initial, and the vertical distance is 0.8. So we can say this is 0.80 meter vertical and theta is the 30 degrees. So what we can say is, right now again using the same concept of conservation of energy, we can find out that mgh plus, initially there is some energy, right, which is your rolls without slipping. So half m v square plus half m omega square. So this is my initial energy, and this energy is being converted into your final, which is half m v square plus half m omega final square. So this is my initial and this will be my final, okay. Now one thing we can say that this is v, this is omega initial into r, and this v is omega final into r, okay. Or what we can say is, this we have already calculated in the above part. So I can, instead of this, I can directly use this equation, right. So this is one and the same thing because we have already derived above. So we can say that this is 3/4 m omega initial square r square, and this will be equals to 3/4 m omega final square into r square. I hope it is understood how we get this equation from the A part, right. Now this is initial and this is final. So we have to find out final. So m, if I take common, it will get cancelled out. Now rest, this is the vertical height, okay. Now if you want to find out omega f, rest all values are given. So just put up the values, 9.8 times 0.8 plus 3/4 times omega final, initial is 5 square, radius is 0.2 square, this is 3/4 omega final square times 0.2 square. Now when you solve this, do it in your calculator, you will get something around omega f, as I have already done the calculation, 16.92, or you can say the omega final is 17 radian per second. So this is your answer for B part, okay. Now for C, we have to find out the angular acceleration, right. So angular acceleration we have to find out. So we have omega I, we have omega f, we have s. S is the displacement. Now displacement is not the vertical displacement, displacement is this one. Now using trigonometry, this is theta, so sine theta is, sine 30 is 0.8 upon the distance d, that is what it is covered. So d is 0.8 upon sine 30, right. So we are using omega f square is omega I square plus 2 alpha into s, which is 16.92 square, 5 square plus 2 times of alpha times s is 0.8 divided by sine 30. Now when you solve this in your calculation, you will get something around 89.152. radian per second square. So you can say 89 radian per second square as the alpha for C. Okay. If you have any doubt, just comment below. Now, what is the net torque? Now, everybody knows that the torque net is I times alpha, where I is half m is given to us as 4 kg into r square 0.2 square times alpha, which is 89.152. Now, when you solve this, you will get something around torque as 7.132, or you can say rounding off 7 Newton meter. Okay, so I hope you have got the question number 2. If you have any doubt, just comment below. Now pause the video, train your mind to solve question number 3. Okay, so here y fragment y must also rotate about a vertical axis, but in opposite sense to that of the x. So we know that this has to be done in order to conserve the angular momentum, because angular momentum has to conserve. So to conserve angular momentum, they have to spin in opposite direction. Okay, calculate the angular velocity of y. Now we can just use the principle of conservation of momentum. So let me use it downstairs. So B I am using by principle of conservation of angular momentum. We have already known I x omega x is equals to I y omega y, angular velocity of y. Now if you read the question, they have already given that the moment of inertia, this is for x and this is for y, and x has the angular momentum as 5 radian per angular velocity as 5 radian. This is for x. So the yellow highlighter is x, and we have to find out for y. So I can simply say that 8 times 5, this is 8 times 5 is equals to 16 times omega y, right? So omega y will be nothing but 2.5 radian per second. So this is quite easy. I hope you have understood this. And the last part is rotational kinetic energy. So we know that rotational kinetic energy is what? So E x upon E y, we have to find out half I omega square, I x omega x square upon half I y omega y square. Half and half gets cancelled. I x is 8, omega x is 5 square upon I y is 16, and this is 2.5 square, right? So simply while solving this, you will get the ratio as 2. Okay, so this will be your answer for the C part. I hope it is quite clear. Now believe you can solve question number 4. Pause the video and solve. Yeah, this is quite easy. So we have to find out the angular speed of the ring. So always remember the angular momentum. Okay, angular momentum is also equals to mvr, and mvr is equals to I omega, right? Now moment of inertia is given to you, mass is given to you, radius is given to you, and the speed related to the ground is also given to you. So omega we have to find out, right? So we can use this as 0.18 times 0.8 into 0.5 is equals to 0.2 times of omega. Now when you solve this omega, you will get your answer, which is equal to, I have already solved, so you will get 0.36 radian per second. So guys, how we get this angular momentum mvr is nothing but the moment of inertia is generally mr square and times omega. Omega is written as v by r, and this r and this r gets cancelled, so we get the general formula as mvr, that is assumed when the moment of inertia is equals to mr square. So mvr is equals to I omega. Equating this, you can simply get the answer. Okay. Now question number 5. You can do it. Pause the video and solve. Okay. Now this is quite easy. First equation is simply the gravitational potential energy is equals to half I omega square plus half m v square, right? So this is the equation to represent the transfer of energy when the mass has fallen a distance of h. Okay. Now the B part is just using this equation to get the answer for the moment of inertia. Okay. So what I can say is mass is 0.5 and times 9.8 times the distance that they have fallen is 0.5 meter, 50 centimeter is 0.5 meter. This is equals to half I, we have to find out again v by r is equals to omega. So v is given to you as 1.14 square upon 0.24. So this is the whole square plus half mass is 0.5 kg times v square is 1.14 square. Now if you see this equation, only I is unknown. So solving for this I, you will get something around 0.19 kg meter square. Okay, so this will be your answer for B. I hope it is quite clear. Now this is a good question. Believe in yourself, you can do it. Pause the video and solve. Okay, now for solving the A part, the rate of change of moment of inertia, it means with respect to time. So can I say delta I over delta t? They are asking rate of change of moment of inertia, right? So change in moment of inertia with respect to time. Now this can be written as moment of inertia is mr square. So here the mass is changing. So delta m over delta t into the radius square, and delta m over delta t, the rate of change of mass is given to you. So 8 gram per second. So 8 into 10 raised to power minus 3. This is the change in delta m over delta t into, and the distance is 10 centimeters. So this can be 0.10 times square. Now when you solve this, this will come out to be 8 into 10 raised to power minus 5 kg meter square as minus 1. So this is the rate of change of moment of inertia. This is the answer for your A part, right? Now for B, which is the angular acceleration, that is alpha. So just check, can I write like this, that I omega, change in omega over change in time is equals to I alpha, and here change in omega is not taking place, change in I is taking place. So I can rewrite this as delta t as omega. So and this will be decreasing. So because addition of mass will decrease the angular acceleration. So this I can say alpha is equals to delta I over delta t upon omega upon I, right? So delta I over delta t we have already calculated, 8 into 10 raised to power minus 5. Omega is not changing as it is mentioned in the question. So this is the initial omega, that is 5 radian per second upon moment of inertia, which is 0.04. This is also given in the question. Initial angular velocity is 5 and this is the moment of inertia, right? So when you solve this, alpha will come out to be something around minus of 0.010, or you can say radian per second square, or alpha is in magnitude, alpha is 1 into 10 raised to the minus 2 radian per second square. So I hope you have understood how I have solved. This is nothing but the change in rate of change of angular moment of inertia, that is the change in angular momentum is equals to rate of change of angular momentum is equals to torque, which is I into alpha. Here omega is not changing, so the delta I, the moment of inertia, and its angular velocity is the initial angular velocity, and no external torque acts on the system. So we can use the angular rate of change of angular momentum. So using this, we can say that alpha is equals to change in rate of change of moment of inertia upon omega into omega upon I. If you have not understood, please comment below. Okay, explain whether the acceleration will remain constant as the sand is no. So you can say that no, acceleration will decrease as moment of inertia will increase. So you can say moment of inertia is in the denominator. So as mass is added, moment of inertia increases, so the magnitude of acceleration will decrease. Okay, so this is all about your moment of inertia, angular momentum, and conservation of angular momentum, and the kinetic energy associated with the rotational mechanics. If you want to get 7 in your IBDP physics, there are 3 steps for physics success with me. Follow these steps, and if you want to get in more details, scan this QR code to have a personal chat with me. See you in the next video. Till then, please share and keep learning. Bye bye.